Okay. Clemens, it is an honor as usual to get to speak with you.
Steve, I'm always happy to see you, and it's a great surprise that I found you in this room.
It's funny, you should be surprised to find me on this continent. It happens frequently with you, but seldom with me.
Actually, if Microsoft would let me over here more, I would be over here more, but they don't let me.
And then you would not be able to do your job so well back when you only went around shooting off with.
That's true.
Giving talks.
Yeah, but the minuscule 2.5 days of vacation per decade that you're getting in America makes things hard.
So enough of this. We are now done with the first talk, which was our effort to put in place all the different products that our division has. One of the things we struggle with now that our division has grown to be encompassing these 3 business units and so on is ourselves to get that story straight. But now what we're going to do is have 4 talks in a row, 1 today, 2 tomorrow, 1 on Thursday. They're going to take a survey of the various main ideas that motivate us architecturally as we look forward to making it easier for you all to build connected applications. We're going to talk about logic, the stuff that actually runs your app, the things that get done. We're going to talk about data. We're going to talk about presentation, particularly how we can reason about the special problems posed by a UI component in a distributed app. And then we're going to talk about security.
But that was almost like a dance.
It was very well done, Clemens. And what we're going to do with these talks is have them in the same order, each of the 4 talks. I'm going to start and talk about patterns. And then depending on how the talk goes, the second part, which tries to connect the patterns with some technologies, is going to be done either by me or Clemens. And then instead of trying to do demos, which always seem kind of odd to me in an architect talk, because you want to be talking about broad ideas and their applicability rather than looking at code. So instead, we're going to try to go over a set of scenarios and use those as the rhetorical replacement for the demo to try to ground the patterns we're talking about in specific situations. And so the goal with each of these talks is you come away with some ideas in your head of how to think about these areas. And so I'm going to start by talking about patterns. Now, when I first learned to program, we were back in the days when the notion of a subroutine was actually controversial. And if you all get into the argument about whether or not service orientation is too expensive, or whether or not it's too costly, you need to use objects or whatever, you're having that same argument 30 years later. There's a constant argument between decoupling and performance. And what's happened over the years is we've learned that as applications grow to broader and broader scope, we have to be carefuler and carefuler about coupling as architects so as that we can avoid unnecessary coupling. And so what we've decided by looking at all the pattern books, like if you go look at a big connected application pattern book, they have a broad mass of patterns in there. They'll go back and forth between a hash table and a queue, thinking that they're somehow the same, when in fact one is an implementation pattern of a distributed app and the other is a structural one. And so our notion is that if I want to look at the list of patterns I have to understand in order to think about the architecture of a distributed app, there are these 3. And so what I want to do is talk for a few minutes about these patterns so you'll understand what we mean by them. The first pattern is calls. The pattern goes, I want to be able to trigger computation and some other components, and I want to wait till it's done, and I want to get back the results. Calls are really useful when I'm dealing with some person and I got to get them response. And so calls typically arise today in connected applications out of situations that start with the UI. But calls are particularly easy to deal with locally, right? Like I said, I come from the day when call was an elegant way to replace a goto with some data shoved into a variable in a common area so that you could abstract from the particular call stack. Call is a nice, decoupled way of moving from one component to the next. One of the advantages of it is that it maintains single-threadedness between the caller and the callee. So it doesn't introduce the complication of having to suddenly deal with synchronicity, with multiple modules accessing the same resources. Very common pattern, use it all the time when we're building local code. Of these 3 patterns, it's the most coupled pattern. But one of the things you're going to find is as we go from broad scope to narrow, a degree of coupledness becomes more and more justified. Since you're running in the same app domain, sharing the same memory, working on the same thread, a call is often a useful pattern. The second pattern is about still maintaining this single-threadedness, if you will, by which I mean never are we doing more than one hunk of work at a time. But now when we're using this thread metaphor, instead of having a call happen where I'm going to initiate some work and wait till it's done, this thread pull pattern involves initiating some work and then letting it happen later. So I'm decoupling the initiation of work from the processing of work. Now, we all know that this is a pattern that we'll talk about locally as a Einstein or high Elvis pattern, because you need to start dealing with resources in a pretty rich way locally. But at the same time, this is a pattern we use a lot in local programming because our UI tools are built around it. And the thing it gives us relative to the call is the ability to decouple execution. Because I typically take work and move it someplace new, instead of having access to all the resources in my environment the way I do with the call, in theory at least, the thread pool moves the work to some whole new place where I've got to be explicit about the data and the resources that are available. So it's less coupled and somehow trickier to use, but it's the pattern of moving work from one place to another and then continuing it in a disconnected way.
I just love the fact that you just called this a high Elvis pattern. I can exactly see how that looks.
Clemens, you're thinking about some disparaging drug use reference to a cultural icon in my country.
Yes, and I actually heard the guy just scream.
Really?
Yes.
You heard it. So that's because it was pointed right at you.
Yeah.
See there? This will be a growth experience for you today. You will have spoken with me, and you will learn about the little guy.
Thank you. Thank you, Steve.
You're welcome, Clemens. So the least coupled of the three patterns we talk about manifests itself in local code as events. When I set up something to go into a thread pool, I have a good faith that eventually, once and exactly once, that thing is going to run. So I take the work and separate it from my call path, but I still have this notion, like in a call, that the thing I'm activating is going to run one time. Events are the least coupled of all processes because I have to count on the fact that there could be any number of people responding to the event call. You know, the CLR gives me a nice metaphor for this, and anybody can walk up to my event and hook it. And then when I make the call, my application has to be happy if nothing happens or if 10 things respond and process the same data. So let's recap. There's three patterns here. There's the direct call, there's the thread pool, and there's the event pool, the event call. And those are patterns of increased decoupling and increased complexity. The complexity in eventing is rich enough. Think what we did to let people deal with it in WinForms. We had to invent the STA so that we could make sure that even though we were firing events out to all these different people, we still were only running one thread at a time because we didn't want the user to have to deal with concurrency.
It's single-threaded apartment for the innocent.
I dream of the days when I could be that innocent again. Before I became a PM and then an architect, I was actually the dev lead on DCOM in Windows 2000. So I have an unfortunate over-familiarity with these apartment models. I used to, my first year that I came to Amsterdam in 2000, I was here to explain the STA.
Oh, that's why you were here. I thought you were here for drinking.
Oh, Clemens. And the horrible thing was,
you did really well on that one.
In the CLR, there was a bug where if you called sleep, the CLR command sleep, after the machine had hibernated, it wouldn't sleep. And that makes demonstrating multi-threading particularly complex and embarrassing. Oops. So now the interesting thing is these same patterns that I just talked about, which is the complete set of patterns that you have to trigger code locally, are also, to my mind, the three major patterns that we use in distributed applications. So if I project calls out to a distributed application, I have the N tier. N tier, you know, we used to call that WinDNA, and because we were focused mostly on distributed apps that were grounded in a client and backed by a database, we used to focus on the kind of apps where this pattern fit really nicely, where you were making calls through agents in the middle, but eventually to a database. And you wanted the client to get immediate feedback for the work they were doing. We all know that as you get into into distributed apps where coupling becomes more costly, this pattern becomes increasingly difficult to deal with. You have a lot of coupling. You often have type coupling. All of these modules are usually built to a particular purpose when you do this pattern.
You have time coupling.
So this, nonetheless, is a pattern that's the most coupled of the distributed patterns. But even in a world where we move to richer and more decoupled architectures, this is still a very useful thing. You know, if I have a head tracks application at Microsoft, which is an app that works against the
Human resources database.
there you go. Thank you, Clemens. When I'm
always happy to aid your aging brain.
And you know something? If I didn't have someone like you around, I would be 1/10 the man I am.
I'm extended memory.
Extended.
Just go ahead.
All right. So the point is there are all sort of patterns when in fact this is the right thing to do, right? I don't want to do my bug manipulations in a queue that's going to run tomorrow, right? I want to make sure I'm doing them right away. In low-scale, direct access apps, this is a fine pattern. But it becomes increasingly unuseful as things scale out or need to be more reliable or more manageable and so on. And so we have the second pattern, which corresponds to a thread, which is a queue. Just like locally, when I schedule a hunk of work to run later on a thread, just so when I drop a message into a durable queue or a volatile queue, my expectation in the pattern is later something is going to pull that message out and process it. Pattern that's been going on 20 or 30 years. Lots of, pretty much every software vendor has an important infrastructure for supporting it. And the reason it's useful is because it smooths out access load, right? If I put all of my work into a queue, I can happily work on it as fast as the back-end machine can go. And if I get too much work at a time, I'll just slow down my response time, but that's fine because the system is working as fast as it can.
And it's older than the N-tier thing because it's a stack of punch cards.
Did you make it a stack? That's not a stack of punch cards. That's a disk. Clemens, you're lying.
No, they're just rolled up a little bit.
And there's your fine graphic skills on display. We didn't think it would happen, but there it is.
I'm astonished that I can still read my writing.
Yeah, I am too.
And other people hopefully too. You can speak to it, so you can read it.
I think that the customers who are here today, our friends, can all read it.
That's wonderful. Cool.
And so this is a major pattern in decoupling precisely because it removes the generator of work from any direct relationship with the processor of work. Now, the most flexible pattern, I would think, would be the pub-sub pattern. And here what happens is I deposit a message into the infrastructure, and an arbitrary number of people can process it, n of them, 0, 1, n. The system can be durable or not durable. I distinguish between the queue pattern and the pub-sub pattern not so much because of durability, because I don't think queuing is necessarily distinguished by the fact that there's a disk, but rather in the queue pattern, I know that it's only going to be processed by one being later. I put a purchase order in a queue, and I don't expect 3 systems to pick it up. I have specific expectations about the behavior that's going to go on the other side. Whereas with the pub-sub system, I'm working hard when I'm doing the pattern correctly to be completely indifferent to whether anything's plugged in there. I do some work, I generate an event, a message in a pub-sub system, and I put it in there. And that part of my app design, my architecture is done. And later, if I want to do something else, I plug it into that backplane, have it grab the right message, and do the right processing. So there's our 3 patterns: calls, threads, events locally, N-tier, queue, and pub-sub globally. If you look at a big old app like an online store, you're going to find that real applications often combine any or all of these patterns. We want to leave most of the scenario work till later when Clemens is talking. But if you think about an online system, the storefront is always done using N-tier because I'm trying to order things and I want direct response. I'm building an order. But they don't want me to hold a lock on Harry Potter when they're about to sell 5 million copies, so that at the end they put my order in a queue and they process it there. And finally, the message pops out, and now its status is there. It goes into a pub-sub system where they might generate a mail saying, I'm sorry, we're sold out of Harry Potter, you'll have it in a week. And so a real app is about finding the right places for those three patterns. Direct interaction at relatively low scale for N tier, disconnected processing for Q, and multi-processing in an arbitrary decoupled way for pub sub. And you look at your application and break it down to pieces where those patterns fit.
All right.
I didn't know that that would work.
No, I had a brain fart.
Well. And so my belief is that those patterns actually suffice. That all the other patterns that I know of are merely combinations or elaborations of those three patterns. Now, I would love to get into a discussion with one of you later if you believe I'm wrong here, because we're going to build this into the product eventually, this notion. And so I'd love to hear it if you think there are other patterns. My belief is that these three patterns, in the same way as they are complete in the CLR, all you can do is fire an event, make a call, or schedule work on a thread. Just so, out in the distributed app, all you can do is these three things. And all we're doing when we design an app is drawing circles around pieces and finding the right pattern for each one.
So mind that there may be details about those things which we are not saying here, but if you look at a classic pub subsystem where the source knows all about its subscribers, or you have something like an event bus where the subscribers actually filter out what's interesting for them, it's still pub sub. It's still the same thing. So there may be differences in the particulars, but that's all there is.
This is called, in fiction, Clemens, pre-shadowing, where you basically go through the next 6 slides really quick and tell them everything that's going to be in them.
No.
Yeah, I think that's what you just did. You watch. I will ask these people at the end whether you did that. You wait till I do that to you, Clemens Masters.
I didn't.
I will go back in your chair. Thank you. And the point to remember as we finish this section about the simple patterns is that each of those three patterns on the Microsoft technology stack can be implemented with a variety of technologies. BizTalk is really good, for instance, at implementing either the detached or the, either the queued or the pub sub pattern. It's particularly prone to reliability, and so it doesn't let you do quick flighty messaging. It's trying to make sure that the messages are reliably delivered because it's aimed at the integration scenario where that's the right way to go. If you take an app like the global bank sample that the company has and try to port it to BizTalk, you'll see it's very poorly suited for a rich N-tier application because it's just not the right thing to use for lots and lots of N-tier kind of calls. WCF is really good for working the N-tier call as well as ASMX and enterprise services. Like I said, that's the traditional application model we were focusing on 10 years ago. But WCF can also be used to implement the pub sub pattern, and it works fine for queuing, either directly on MSNQ or as an API over Service Broker, a different queuing infrastructure at the company. And so these technologies can be used to build out these patterns. And one of the goals of our division over the next few years is to make it easier and easier for you to identify when the right pattern's there and then not have to make such big hops as you move from one pattern to another. Over time, we'd like it to be, our stack to be such that you can build any of these patterns and have the same kind of experience. We don't want to be in a world where you use TIPCO for one pattern and MQ for the second and your Java code for the third, right? We're trying to get it to the place where the stack does all of these patterns. Now, one of the things that happens when you think about the fact that there are these three simple patterns is, in reality, you get assaulted as an architect with this long list of patterns. Each of them have varying names. I bet a nickel if you went and typed each of these things into the
live search,
into the Wikipedia, you would find an article that would describe them. And if you went and looked, you'd find it very difficult sometimes to even figure out what the difference is between the two articles. But the point is that in order to really understand these things, you have to think about 2 points. First, despite what a purist might say, these are largely descriptions of product offerings to build applications rather than actual architectural patterns. And second, if I have a platform that builds one of these things, it's in my interest to start adding more features to it to make it competitive. And so if I start out with an enterprise service bus and then try to compete, I'm going to add more and more features. And finally, using my offering to define enterprise service bus is kind of tricky because I've added all sort of things that wouldn't be in what a purist would call ESB.
And then there's also bleed across business domains and technology domains. So if you look at service-oriented architecture, from a technology perspective, what does that mean?
Mm-hmm. And so that's what we're going to talk about here. I want to go through a few of these pictures and try to tack down a little more what how I think about these patterns. In addition to us wanting to support the simple patterns, we'd also like to say walk up to our platform and build an ESB. But our thought is that in addition to it being a statement about a particular communication pattern between logic modules, to get a handle on some of these architectural patterns, you also have to think about the infrastructure services around it. Sort of in the runtime of the system, you've got things like transactions and security and discovery and relay, features offered by the platform that aren't about the architectural pattern itself, but rather about something that you access when building out your app, something as important as the connection pattern, but different. The second domain is in the monitoring and IT pro experience, where an application needs to be watched while it's running. You have to have some handle on it. And so our notion is that if you look at some of these other application patterns, what you're going to find is they carve off a piece of this space. And so what we've been doing during our planning process, which is going on right now, of course, we're doing it in a much more complicated way than this, but we're drawing a basic picture of these services, the runtime services, the management services, and then the basic module patterns. And we're saying, imagine a Visio-like tool that let you design and implement a pattern like an enterprise service bus. Visio lets you, when you're doing any particular thing, only have a subset of all the shapes it knows. Just so, what are the subset of concerns that are common in these higher level patterns? And so, for instance, if I look at an ESB, it strikes me that an ESB makes very little constraint on what the actual communication shape will be. You can run a queued app or a pub sub app or even a tier app on a rich enough ESB. The ESB tends to be rather rigorous in the particular commitment it makes to a messaging format. ESBs that are sold with a lock-in marketing strategy try to convince you to start using it, and then all the messages better be going through that ESB or you have a new integration problem. But what ESBs are about is providing a backplane into which you can plug modules, and then a whole rich set of services for both management and the runtime environment in which those modules happen. You can, once you plug your modules into an ESB, you're then establishing domains of transactions and domains of security and so on. So we think of ESBs as pretty agnostic in terms of actual application shape and rich in the infrastructure services. And of course, like I said, each one is going to compete with their particular subset of the infrastructure systems that it implements.
The funny thing about ESB is that if you look at a lot of products which are called ESBs, they're actually not Bs. They're hubs.
But ESH doesn't sound nearly as...
That's true.
It just doesn't work. But it is true. We don't have yet a technology that lets us do a federated ESB, where I can walk up and plug in software. Think of an ESB as a rich set of services on top of
Ethernet.
Ethernet, right? So you would have naming, and that would be DNS. You would have addressing, and that would be IP addresses. Well, imagine a world like that where you can bring machines in, take them out, get security and transactions. But you can just as easily have one of those machines be an employee's laptop as a back office machine. That would be a real distributed connected ESB. And what we typically have instead is systems running on servers talking to one another that are a set of hubs, hooked together in a hub and spoke way.
So if you have two machines and the two machines are somewhere in your data center and they are the ESB, be very suspicious.
I wouldn't be suspicious, Clemens, because ESB can name anything you want.
That's true.
It worked. They called it an ESB. Why are you suspicious? You are a German idealist, aren't you, Clemens?
I am.
Long Hegelian tradition of
and
being...
socialist.
I don't think of you as a socialist, you rich guy.
I give to the poor.
Uh-huh.
That's how I feel. Poor.
That's why you give all your money to yourself.
Exactly.
And then you don't feel poor anymore. So the second pattern we want to talk about is the enterprise application integration pattern. BizTalk is a great example of a product like this. The point of it, EAI, is not necessarily something you build apps on top of, but rather something you use to hook apps together. And EAI will often have a little bit of influence on how your app logic works, because either you have to hook your app into the EAI in a certain way or communicate it a certain way. Not all EAIs support all three logic patterns pretty well, but EAIs pretty nearly want to take over your communication, right? Some EAIs are all about coordination of applications from the inside, and some EAIs also sit on the outside and hook up your application to people calling from afar. And typically that federated stuff is typically request reply because you're often using standards, whether the bus that's inside hooking your apps together is more likely messaging. And so what we try to picture here is that EAI has a few services that come with most of them, like the ability to manage identities, single sign-on, that sort of thing, to make it easier to deal with the security of the apps you're putting together. And also EAIs almost always provide some ability to monitor and manage the operations of the separate apps, at least as they're communicating across the EAI backbone. But unlike an ESB, which is intended to be the backbone of a particular app, EAIs are intending to hook apps together. But they're still using the same pattern. You know, they're typically using a queue or a pub sub pattern to do this hooking. So they're not changing the patterns we're using, they're just changing the particular purpose we're putting them to, and then adding a bunch of features appropriate to that purpose. EDA is one of the late hip things. You know, when Clemens and I were in Malaysia a few months ago, we talked to an analyst, and they said, oh, you know, they want to spend the whole hour teaching us about event-driven architecture as if it was a pretty new thing. And I wanted to ask him if he'd ever met anyone who worked at TIBCO, because this is a pattern we all know for a while and many people use. But EDA, unlike the previous two patterns, is an architecture that makes a pretty strong commitment to a particular communication style. One of the funny things I'll find with people do event-driven things, you know how when these things first come along and everyone is an idealist and they want to say all apps have to be EDA. And so they'll hook the front end of their database access to the EDA bus, and then they'll hook their database up, and they'll be sending messages into this bus, and they only ever go to this one database. And if that database goes away, the app breaks. And you'll say, why don't you just hook that client to that server and call it a day? That's what you got. But because they're running it through an EDA, it's decoupled. Mm-hmm. But a true EDA architecture provides an infrastructure where you get really rich and performant distribution of events or messages. Don't want to worry too much about the difference between the two. And you build your application by building decoupled modules that are all reacting to the individual messages, doing rich content filtering, distributed queries if you can, and so on. So here we typically have just the latest manifestation of a real rigorous and rich version of the pub subsystem. We're putting messages onto a bus and letting things deal with it that are unbeknownst to the sender. Message-oriented middleware turns out to be very much like EDA, with the exception that it's more often queue-like and durable. But you want to go try to figure out what the difference is between message-oriented middleware and EDA, you're going to find it's purely the specific difference between products. In both cases, there's a thing in the middle, and you put messages in there, and you plug other things in. And you may have standards in terms of the APIs you're using, and you may have, you know, proprietary lock-in things. But it's all about sticking messages in the middle. Like I said, MOM systems in my reading, and I'm not a marketing expert on these things, but they tend to be more queue-oriented, more transactional, slightly more coupled, given the apps that are built. But again, it's a queuing or a pub sub infrastructure focused on messaging. Very rarely will you see a message-oriented end-tier architecture, you know, building an end-tier app out on a message-oriented middleware app. B2B is unusual because B2B infrastructures are trying really hard to connect to the external world. And they typically, these days, will implement some standard interconnect that allows me to be more tightly coupled across a basic request-reply interface. Virtually all the B2B systems I know are either direct messaging or direct request-reply. Especially when they want to get into standards today, they tend to be request-reply in fact, if not in name, because they're using HTTP. But these systems impact your communication pattern because they typically support particular interconnect patterns. So at least the part of your app that's up against the B2B connections are going to be constrained in what they do based on that infrastructure. And that makes a certain amount of sense. Typically, we don't put really high bandwidth over those kind of connections, and we don't do immensely time-critical things. And so if you want to build a Qt or a pub sub app that connects to your B2B, it's okay to take the copy hop and put it into your infrastructure, return answers later. But again, no new patterns implemented. Finally, BAMs really don't have anything to do with the app at all, right? What our BAM offering is about, in fact, is walking up to an app once it's kind of done and sticking as inputs the data that you want to be able to pull out of the messages as they flow through the system. So you can do rich analytics. What's cool about a BAM thing is if I'm just generating events to roll the spinning balls in MTS, all I know is that a call arrived and went away. Whereas with the BAM system, I can add information to the call that says, pull out the purchase order so that I can know that that event was a spinning ball about that purchase order. And combine that with a rich analytic platform so that I can go study that data after the fact. I have a really powerful tool for watching my processes in flight. But again, you can do that pattern on any architectural application pattern, right? It doesn't matter whether it's N-tier or pub sub or Qt. So here we are. We've kind of walked through a bunch of the patterns that people use at a higher level, a bunch of these architecture patterns. And this is where our thinking goes, that we're really only dealing with 3 actual architecture patterns: pub sub, Q, and N-tier. And a lot of these other things that people call patterns or business models or architectural systems are nothing more than particular kind of infrastructures to build these basic patterns. Oops, I forgot one, app server.
Oh, yeah.
App server is what we should have called MTS 10 years ago, but we didn't.
But everybody else did.
Yeah, and so we have an app server, but we give it away with Windows. And so
it's true.
We could have made more money or something. But an app server is all about the infrastructure in which you run your logic, right? There's a funny distinction in the world today between an app server, which I think is mostly about stateless N-tier shaped apps, and a process server. And I think the difference between a process and an app is that a process is built with workflow or lasts a long time. Maybe it's built more on pub sub. But these servers, whether they're a process server or an app server, are about an environment which runs these things and provides infrastructure services. But still, we haven't changed the patterns.
I have to say, I'm really thankful that you've cut through all the marketing thicket for us now.
See, in the first talk, you actually allied yourself with the marketing by putting pictures of boxes up there.
That's true.
Whereas if there was any of our marketing team in here, I would get in trouble when I went home.
That's true.
You haven't seen their little spanking machine yet, have you, Clemens?
I think you just made a formidable display of just destroying the whole picture of marketing terms here.
Well, this is why they have product guys come out to TechEd occasionally to talk just about the technology.
That's cool.
Because what we want to be able to do, obviously, is not have to build 20 different tools and 20 different runtimes. We want to have a single runtime with a bunch of infrastructure services. And then we want to help you if you believe you're building ESB app or whatever. We want to help you subset the problem and let that be used to focus you. But we want to support a single platform that you can use to do anything. And that's where these ideas have come from. Like I said, a lot of these ideas are what we're working on now to organize our thinking over the next release or 2. Now, Clemens here is an idealist and will say things like, that is stupid, whereas I'm not that kind of guy.
You will say that's relatively stupid.
Yes, because I'm a relativist. And so I stand on the right-hand side of these things. I'm not the kind of person. Do you remember Pat Helen used to come by, and he said, every application has to be a queue in a single module.
Well, that was the second thing he said.
What is the first thing he said?
The first thing he said, I believe, was everything needs to be a direct connection, needs to have a transaction around it.
Yeah, then he left the transaction team and he had to turn against us. That was horrible. I cried the first time I heard this.
You did?
Yes, I did, Clemens. I'm sorry I shared this emotional experience with you in the middle of business. I apologize.
Sorry.
But I'm the kind of person who tends to think that what you want to be as an architect is somebody who has all these patterns in your pocket. And you don't want to be listening to people who tell you there's only one or the next big one, because they seem a lot alike. Instead, what you want to do is to be able to say, there's a base set of patterns, and I might not be right about what they are, but there's a small set of patterns and a small set of infrastructure services. And when I'm looking at my app architecture, what I want to do is find the right ones for the job. One of the reasons we as platform vendors tend to push people into a more extremist architectural stand is, once you've got a team full of people that know about queues these days, it's hard to get them retrained onto another tool set. And so you've heard us talk about WCF this way, and it's going to be a continuing goal of our division, is to make it such that you can use all these patterns with the same platform. So you'll be able to judge me in 2 or 5 years based on the success. Excuse me. So I'm going to talk a few more minutes before I pass over the baton to Clemens. And I want to talk about the split between imperative and declarative coding. This isn't so much an application architecture idea as a implementation strategy. But the reason I want to share with you is when you understand why we're thinking about moving more and more of our focus from imperative coding strategies to declarative model-driven strategies, you're going to see a big hunk of our future direction, and you're going to start understanding what we intend to do to make life easier, how we're going to improve performance, productivity in the next generation of products. So over here is an app, and it's a little simple app that does WCF. And the top line declares a binding, which is a description of a connection pipeline in WCF. And the second creates one of our hosts so that we have an endpoint created. And the third adds that binding to the host. So we'll say the service named the type of the service that I pass in is now going to be exposed on the binding that's called the WS-HTTP binding with a particular security mode. Create the binding, create the host, add the binding to the host, and open it. Now my service is listening on that binding. Now, if I implement it this way, it's all in code. And so that's all hard-coded. And the app as delivered to the operations center is bound to that particular communication style. What happens if I want to change how it does security or change how it works? And so what we try to do is to walk up and start building you tools that allow you to remove information from code and move it over into configuration, into metadata, into a model. You want to think architecturally that the word model and the word metadata is all about getting stuff out of the app where it's hard-coded and compiled and into stand-aside data that you can tool and modify without recoding. And so the first thing I do is I walk up with my configuration tool and remove the description of the binding from the code and move it over into the config system. Now, after you've deployed this application, if you want to change it so that it's running on TCP, you can just go ahead and change the configuration. You don't have to modify the app at all. Some of the map people in live have just implemented a WCF application, re-implemented some of their applications in WCF. They did this over the summer. And once they got it implemented and using the standard protocols over HTTP, they just changed the binding from HTTP to TCP. They've saved millions of dollars already by decreasing their bandwidth and latency and reducing the number of machines that their app needs to run on. And that can be done purely by reconfiguring and moving to the more efficient protocols that are available with WCF. The second thing we can do is walk into WAS to WAS configuration or to IIS configuration and change the way we're linking the service to the binding. So I first changed how I define the binding, and now I've changed how I link the binding to the service. I've moved all that information out. The upshot of this is that I end up having code which just creates the service. And all the information about how it's wired to the world has been hoisted out of the service. This gives me more flexibility with my coded artifact once I deploy it. So there, in a nutshell, is why we think moving information out of code and into configuration or into metadata or into models is useful. Because it gives me more flexibility after I built the thing. Everything needed for correctness is in the code artifact. Everything that's optional at deployment time is out in the metadata. So now we get those basic deployment ideas out. Let's start looking at my application and see if I can't do the same trick. Lots and lots of applications have structures like this, where I go up and have conditional statements that decide whether I'm going to run certain kinds of things. And so if I focus on those kind of objects, I might want to be able to see if I could hoist those out into metadata as well. And so what I do is I use one of our editors to edit rules. And now I can provide a very much more friendly tooling experience to specify those rules. And more to the point, I can host them out of my code. So if the condition is telling me that I have a particular check on whether the caller is in a role, or I have a particular other kinds of checks like, am I giving the right discount to the right people, I can start using this much more clean editing feature of this tool and get that data out of my code.
And if the business rule changes, you can change it outside of the code in the metadata, and you don't have to recompile your app.
And so what you do is you make a link where now the metadata is out in the rule editor, and all I do in code is call out to rule 1 and say, if rule 1, then do this. If rule 2, then do that. Of course, what I do then when I deploy this application is give people either the standard rule editor, or I build the rule editor into my UI. But by using the rules tools that come with BizTalk or with WF, I can now remove logic that I need to change frequently from code and move it out. And I provide, I don't move, obviously, every condition, but the conditions that can be changed and modify the application in a way that is constrained and controllable can be moved into metadata. So these are second reasons why we want to start hoisting data into models, into metadata structures. It's because I can provide better tooling that presents the app more clearly to the user, and I can extend the area where the app can be modified without needing a rebuild. And so what happens is that as the rule editors become richer and richer, the conditions stop looking like code, which is only available to a developer or an architect who has a lot of familiarity with that, and start to be able to be presented in ways that managers can understand. You can walk up to an application and show the set of rules that are working, and an analyst or a manager can say, that rule doesn't look right. We have a special today, and if that kind of user arrives, we want to give them a discount like this. Those people couldn't conceivably do a code review, but they can look at the set of rules and relate to them. And so if you use these rules artfully and name them well and have a good rule editor, it's not like you don't have to have coding experience here, but you can present the application to the user in a more transparent way. Finally, let's look at activities. Activities are obviously what we would call modules and workflows. And typically what I'll do is I'll have a rule that will trigger an activity. And so what I'm calling activity is, once I remove rules, I want to focus on the code that runs based on the rule. And who knows what that code is here, because I don't want to write it all out. It won't fit on my PowerPoint slide. But I can hoist the data out, the behavior out of the code and move it into these activities. Now be real careful, because Clemens doesn't get to give these talks. He gets excited if I don't call your attention to his remarkable PowerPoint prowess. Uh-oh. You going to do something here, Clemens? Oh.
I think that's my favorite slide.
Of the whole deck?
Yeah.
The whole talks?
Can you do that again?
Okay. Clemens has too much time on his hands.
I think it's just an awesome slide.
You should be able to blog more often with these time constraints of yours. Anyways, the point is that when we think about WF, What we hope you to be able to do is pull both the conditions and the behaviors out of your code, and again into an experience where if you look at this and talk someone through it, this looks very much like the kind of data flow diagrams that people have been working on for design for 20 or 30 years. And the goal is to make that even more so. We'd like to have a tool where you could start with a simple data flow diagram and link that to subsections of your workflow that you could implement with pre-canned activities, or maybe you have to send down to the development section to build a few activities that are peculiar to your app, or a set of them that can be reused for a new purpose. But the main structure of your app, instead of being in if statements going through the top parts of the hierarchy of your call stack, is now exposed like this, where errors in logic are much more easy to see. And since this stuff is all represented in a model, we can build tools over time that can analyze these things and help find problems for you. You know, highlight areas where you may have synchronous access to data and the like. So in addition to these three patterns we talked about in the first part, you see our goal in trying to hoist, in focusing on declarative code and trying to hoist parts of the application into models. We can tool it better, we can let you change it more clearly, you can see what the app is doing better. This is going to be a major focus for us moving forward. You're going to see more and more of our tooling and our framework work focused on these kind of metadata-driven things. Clemens, right on time. That's something you don't get to say very often, is it?
It's
4:45.
It's remarkable.
It's constant in your life, Clemens.
What, me being astonished about your precision?
No, me being on time.
Ah. Okay. So one app that I'm always tempted to show you, but then again, I don't have a well-populated enough, publicly showable Outlook because I have all this mess in my email.
Love letters, you married man, you.
Exactly. So, all the love letters that nobody can see. Ooh. Outlook turns out to be the ultimate connected application. We're going to talk about Outlook in length also in the presentation. Actually, in almost all talks, we have some element in Outlook because Outlook is one of the most interesting applications to look at when you think about a connected application, a connected client, together with Exchange. Because Outlook implements all those patterns. So let's look at on the right side. Contacts and notes are clearly an N-tier app. You just go and edit a store. That store may be sitting locally on your machine, or it may be sitting down in the Exchange server, but what you really do is you edit that store. Now, that was the wrong exit, my friend.
I wonder if people are fleeing the exits in the back of this one.
And now he's struggling to get it closed. All right, so it's
Don't bother me, Clemens.
okay,
Go ahead.
you fix that. So so contacts and notes are purely just an editing experience. You have a database and you work on it. In Outlook, if you just look at Outlook, you edit a local database. That's all you do. Then, when you synchronize, there's some synchronization going on, which is usually done with some form of queuing mechanism. Because what you do when you edit a contact, you update your local store, and then you load a queue with the information that it's supposed to be synchronized down to Exchange server. And similarly, Exchange server will negotiate with you what you already have in your store, and if you happen to bring up a fresh copy of Outlook, it's going to bring those things up. But if you look at Outlook as a standalone application, the contacts and the notes are purely just editing a database. The outbox and the tasks are purely writing stuff to queue. Tasks that you, mind you, assign to other people, not the tasks that you write for yourself. Those are more in the N-tier bucket because they are just editing a database. But if you assign tasks to other people, just as much as sending mail to someone, that strictly goes to the outbox. The outbox is a queue, and that queue replicates out whenever it sees the mail server, and then goes and just sends those things off. And they will then be moved to your sent items as an archive destination. So actually the data goes two ways. It goes into your sent items and it goes to the server, but it's purely a queue thing. And then there's PubSub, which is your inbox and your reminders. And it's PubSub insofar as that Outlook is raising events whenever something arrives or a reminder comes up. And the toast that comes up in Outlook 2003 and 2007, that's subscribing to that event. The reminders window that pops up, that subscribes to that event. All the things, the sounds, or the flashing icon, all the things that are happening because mail arrives or because a reminder comes up, all these things are just hooked into the event bus inside Outlook and just firing off when one of those events happens. So you have elements of end tier, you have elements of queuing, and you have elements of PubSub, all in Outlook. And if you drill down, you will find there are even more incarnations of those patterns in Exchange and in Outlook and in very many other applications. But it will be hard, and our theory is impossible to find any other patterns. Anything will boil down to those three elementary patterns. And Outlook is a very good thing to study. If you just look at Outlook, look at the different folders and how they behave when you interact with them, you can actually figure out what the individual patterns are. And it's a very good case study to think about how you can write applications. So the classic case for end tier is, of course, the web store. So I have Windows Marketplace here. And Windows Marketplace is a store where you just go and browse a catalog. And of course, with clicking a category, you create a filter condition on stuff that you want to see. So you instruct the engine at the back end to give you appropriate items out of the catalog and just filter them and present them in a certain way. You can enter custom searches, or you just create searches based on whatever other categorization you'd like to see. You just create a pivot on the catalog. And of course, that all is completely interactive, and it's naturally end tier. So that's how very many web experiences are built these days. Now we have queues, and Steve has a wonderful story about that, so I can just leave it to you.
Which story is that, Clemens?
The 7-Eleven thing.
What 7-Eleven thing, Clemens?
Don't you have a 7-Eleven thing about queues?
We shouldn't name these customers.
Oh, sorry.
So when we were first working on NTS and ComPlus, we had this company come along, and they had to every day send in orders in order to get their stores restocked. And they had a policy that said that everybody had to do this work at 5 o'clock, because that was the time of the day when you sent in your order. And they were running in little, towns in Montana. And I think if you're a European and you've never been to the US, you just can't imagine how far away Montana is from anything. And you can just picture that little wire on the 100 miles of pole between their phone and the next town. Maybe it's not hundreds of miles, but it's probably 60.
It's far.
It's a long ways. And so
Why would anybody want to live there?
Because the land is cheap, and you don't got any rude neighbors.
In America, that's a value.
Absolutely.
Yes.
Whereas I've never met a rude person in Europe.
No,
one
they're
moment of
not.
all the time I've been here.
We're all friendly. We're
Exactly.
socialists.
You got a chip on your shoulder from these right-wing commentators.
Yeah, I listen to Bill O'Reilly every day just to amuse myself, and I just start to believe that I'm a socialist.
But you always voted for those really conservative people who in your country, didn't you?
Let's not discuss this.
Okay. All right.
Whatever is sort of right-wing in Germany is really far left in America.
Absolutely. We got two identical parties that just have different color outfits. I'll give you
That's
that.
right. And the one has a donkey and the other one has an elephant.
Yep, and so when I worked, the only political campaign I ever worked on was John Anderson, because he was an independent, and they had a picture of the back end of a donkey and the back end of an elephant, and it said, "Get ahead for a change." So we were talking about this company, and what they thought, this is a thing that everybody goes through at some point when they're building these kind of apps. They thought that their store managers had to have acknowledgement that they had put their orders in. So all through Montana and Wyoming and Colorado at 5 o'clock, people would fire up this app and get on their rickety little 56K modem and spend a half hour trying to update the order database. And they had a hard time because they were having horrible contention and people were having to wait a half hour and they had never heard of a queue. And so we were able to help them quite a bit with a little bit of consulting effort, and they were a happy customer for a long time. But the story there with queues is the place you see it most frequently is when you want to separate temporally two hunks of processing. And people will always tell you, my user has to have feedback. And I say, okay, put a message in a queue, put a little spinning question mark up. When you get the message back, put the light on. But don't sit there waiting. You don't hold the lock, don't hold the thread. And so the notion is that as we build out these disconnected apps, the only time you see the end-tier pattern, the request-reply pattern, is in situations of low scale, where you're really sitting there, editing your own, purchase in a cookie, that's stored on your machine, and you give the illusion of interactivity, but nothing really happens because they can't scale like that.
Right. We're going to see an example of that in the Visio.
All right.
So then there's, for the same stores, if they want to go and just fan out the catalog of the things that we currently have, let's say we are here SuperCorp, and SuperCorp publishes what they want to be the specials of the day. Of course, all the stores need to know about this, but it's not really interesting to SuperCorp to send those individually because they know that everybody's going to subscribe to that event bus. So they just send one copy of that thing out, and then the event bus is just taking care of getting those things up to all the individual stores. So that's a very simple case for a PubSub. More specifically, I will give you a little Visio. Let's try to see whether we can show that.
So the way we do our planning is we sort of think that planning for a large group is like planning for a small group. So we have a sort of requirements generating activity that's managed by themes, and then they push that into shared architecture, and finally we look at the features we need. And what Clemens is showing you is work we're doing. Remember I told you earlier that these architectural patterns are going to drive our implementation plans. Well, Clemens is building out this particular application as an example of a really rich enterprise app that we want to use to decide what features we need in the next platform.
So what I've done, and I'm going to take those things away, but I'm going to start with those, is we're building this large app, and some of you I actually got that question today, is what happened to Prosware? So I was demonstrating an application 2 years ago here at TechEd, which we couldn't distribute for all sorts of reasons. And that was a little storefront app for a bookstore with a bunch of services, which was an SOA, if you will. It turned out that the application code was pretty hideous. And the reason for that was we didn't have the Windows Communication Foundation those days. So we actually had to use, when we implemented this, had to use all the 5 technologies that were there. So we made a very realistic application, and then in the end, I believe some marketing people looked at this and said, oh, that's very complicated. And we said, yeah. So it turns out building this app with the Windows Communication Foundation today would actually yield pretty clean code, but it was just too ugly to confront any customer with it, I think. I think that was the story. So what happened with that app? Well, that app has now gotten legs, and we're taking that idea, the bookstore, and I'm fleshing this out right now. So it's no longer has this weenie set of 7 services, but we actually have now an accounting system. We have all sorts of places that we talk to. We have B2B partners and all those things. So what I've done, the first thing I've done here is I've colored the areas of communication in this application with the buzzwords. So I've done the buzzword mapping. Underneath all of those services, so you see the picture up above, so it's little tiny, but it won't get any more visual if I've made it smaller, the big app. Underneath all this is ESB, because ESB is not really about the relationships of services per se, but ESB is a hosting environment. ESB speaks nothing about the interconnection of apps. It's purely just about that. MOM, for instance, really only talks about communication infrastructure. It talks about things that are connected by queues, So we have a MOM thing up here, which we can clearly identify. The ESB thing is just a backplane. The ESB thing is a backplane insofar as for using an ESB, let me actually go back a little bit. For using an ESB, this is that area here is the ESB. You need to own those services. So there's a bunch of services here that are out of scope. So these here are not in the ESB because we don't own them. So ESB is our hosting environment for services, but not necessarily others, the hosting environment of others. Then we have things here, such as the B2B links, which talk to other people. So in this application, if you look at any realistic enterprise environment, you will find use cases for all of those things. You will find a use case for an ESB, you will find a use case for B2B, you will find a use case for EAI, which we have here. So here is our wonderful little accounting service, for instance, accounts receivables. That's meant to be, in our example case here, an Oracle system or SAP or whatever vendor you like. That's your ERP system, which has the accounting system built in. So that's obviously an EAI case. For all of those cases, there are certain things that we need to do in terms of providing infrastructure so that they can work. Just as much as Steve gave you the mapping of services or infrastructure pieces, these are the infrastructure pieces which actually go into action in those particular links and connections between services. So let me just go and take that away and let me talk about that app a little bit. So I need to go all the way to the side of this and go to the base scenario. So here we now have it in the clear. So let's start and go up to the web shopping experience that we have here. You put together your web shop. This is also called, this thing here is called the
web shopping experience.
No. I'm thinking what Zinda calls this.
The front end.
No, he calls this the electronics board. He thinks this is a drawing for some electronics.
He's astonished that you have so much time on your hands and you're working for him.
That's right. So we have a web shopping experience. The web shopping experience has a bunch of logic inside of it. We're focusing in this picture purely on the connection qualities of this thing. You have a bunch of request response links going out of this. Current catalog actually goes to the catalog, which lives out to the right, now I'm confused, to the left for you. It goes out to customer profiles, which live out here. So these are all request response links. It's a web shopping experience, and very many of those things are request response. It's also, there's an order validation service here where the orders go when you have your shopping cart together, and it's also request response because that service here is responsible for checking whether the order you put together in your shopping cart is actually okay. And it will give you a warning if it's not okay. So if it finds a violation of the policy, you can't use that credit card because we don't support it. Actually, your shopping cart is too old because the prices of the items changed, all those things. It will check all those things. And all of these things happen in a request response fashion. So this is just this one pattern in action. Turns out if you build web apps, you will have a lot of request response there. Now, if I go further down, so let's see what happens after the order validation stage. So let's go here. Things change quite a bit. The order validation service just exists so that I can vet the validity, the plausibility of that order. I will not go and check the credit card. I will not debit it. I will not go and check my inventory whether I actually have books that are ordered or whatever else. I will do none of that work. I will just check whether the order is consistent and okay. That may be and I do that because that service here is to be used with a smart client, is to be used with a web farm, is to be used with the call center, and is to be used with any application that you may write. Because that's so, I need to have a central place where I can enforce my policies on orders and I can do a pre-validation check of whether things are okay. Once that's done, the story changes. Then you have this red line with the disk in the middle. that goes from order validation to fulfillment, I'm changing into a queuing system. Because from this point on, I say, okay, we've done everything we can to make sure that the order is okay. We've fulfilled our policy. We have nothing else to tell the user about this because the user can't fix anything more at this point. So we tell the user, thank you for your money. We're going to get back to you once we're ready to tell you what the status of your order is. And that's exactly how Amazon works. Amazon says, thank you for your money. They don't say that directly, but sort of implied. But they thank you anyways. And then they will say, we will send you email about the status of your order. So I'm changing to a queuing system, and now I go into fulfillment. The lifetime of the order validation service of this process is a second or two. The fulfillment service, that process may take a week or two. So the lifetime is a lot longer, so we're already differentiating on the service basis between what's the state length. And this will also greatly influence the way how I'm implementing this. The order validation service will likely be a rule engine that I'm employing, which just goes through a series of rules and is done. So just a matter of minutes or a matter of seconds. Fulfillment service is bigger, right? I can go and click this thing, hopefully. At least I used to be able to. And here's my drill down into this thing, and that's actually a complex process. You see that there's still the submit order thing up here, right? But this is a thing that I would certainly do in a workflow if I drill down into it. And here you can see all the complex interactions that actually happen through all those ports that I have. So let's go back here. Let's assume I have, I'm here in fulfillment, so I start processing the order. I have a bunch of inventories that I want to go to. So because I have an order where someone orders 20 items. Those 20 items may not be shipped straight from our warehouse, but we may have partners who ship things directly. So we just sell things for them, but the things come straight out of their warehouse. So we have a warehouse here where we may have stuff in stock. But the warehouse may just be a proxy for some of the warehouses that we actually work with. So here, so we have Tailspin Toys and Worldwide Importers, and they actually ship stuff directly to clients. And all of that stuff, most of that stuff, actually happens through queues because it's done in time. What we're interested in, everything in this process, every single message is worth money. It's pure cash because you're punting purchase orders around. Every purchase order is worth money. You don't want to lose that thing. So thoroughness in the process is much more important than speed. And you want to be prepared in such an environment for the day that Harry Potter comes out, or it's always hard to use an example like this. I don't wish anybody bad. But imagine a popular rock star would get hit by a truck. All of a sudden, everybody rushes. It's unexpected, right? Gets hit by a truck, gets flattened, dead. All of a sudden, everybody's rushing to Amazon buying CDs because they're weeping and they just want to have all the CDs and books about them, and it happens. And all of a sudden, the death of a rock star can cause Amazon to go down if they weren't careful about their architecture. And that's why you should be doing those things with queues and decoupling, because the work will just pile up in front of your system, and your system will just work as much as it can to capacity, but it will never overload. So that's why we switch here in the fulfillment process completely to a queuing system.
You know what, Clemens?
Yeah?
Paris Hilton just won a contest. I read in the paper.
That's what?
She is the person of all celebrities that 70% of all respondents said they would like to see her more than anyone else killed in a gruesome horror movie.
I'm all for that. Did I just say this?
I don't know, Clemens. You often will say you like to kill people gruesomely, so you probably said it again. I feel sorry for her.
But if Paris Hilton was killed in a horrible accident, nobody would go to Amazon. Everybody would go to their next newsstand.
Maybe they would go to Amazon to buy her autobiography.
No.
Would that be something?
Yeah, 2 pages.
she's richer than you are, Clemens.
That's right. My parents weren't so good in accumulating money. That's correct. So the inside of all this is a purely a queuing system. I could spend hours about this diagram, and I have already spent very many hours talking to other people about this diagram. So things change again when we want to report state of the workflow or state of the process. Now let's say we have shipped. So the order has been fulfilled. We have shipped things out, or we're really getting close to it. So we're splitting off one item of the order, and we give that to Tailspin Toys, and Tailspin Toys is delivering for us. Our policy, one of the biggest retailers in the US, that's the policy they use for their customers, is they will not charge your credit card before the stuff actually hits the truck. I mean, the inside of the truck, not the other side. So as you're taking the package and you push it out on the ramp, you scan it, or it's got an RFID in it. You scan it out, and in that moment, you initiate the charging of the credit card. You have previously validated the credit card, so you make sure that you're actually going to get that money, so you have already a verification number. But you're not going to charge the credit card until the stuff is actually on the ramp. We need to get that information somehow out. And of course, Tailspin Toys here has all they do is they have an RFID tag that they scan and associate with the code. Where are they putting this? They don't care. So they simply throw it onto an event bus. Same goes with Consolidated Messenger, which you can think of as being, a package company. Same thing, they have status about their things, and they don't really care where that ends up in what system. They simply throw that status onto an event bus. Now, the event bus is this thing in my picture. That's all it is, just that circle. Now I have subscriptions onto that event bus, which go to particular areas in my system. So let's go and follow that trail here. All of those go back to the order tracking service. That thing is just there to track from all sorts of sources. All the events are going on, so it basically just goes and subscribes to all of those, consolidates this event stream into a single event stream, and then raises events and reasons about those events, has rules for how those relate to the order and what to do with them, and then updates a consolidated order status and then fires another event. And that event is then subscribed to. If we follow that path, by the notifications manager, for instance. The notification manager is the thing that sends email to people and says, your order has just been shipped. Your order is on its way. Your order has just been canceled. Your ship has just sunk. And on the other side, this event also feeds back into the fulfillment service here, where that lands. And I have pushed stuff onto the ramp will now cause the charging of the credit card to commence. We'll actually go and now submit this into the accounting system, and the accounting system is then responsible, the accounts receivable is actually responsible for charging the credit card or issuing an invoice. So I have appropriate things, appropriate architectural elements for any of those areas. After fulfillment, after the shipping has been done, or in that whole process, there's events being generated, and I need to go and concentrate them and drive them back into the system. Eventing doesn't mean that it's a volatile thing, as you know from Windows events, mouse events. They're never guaranteed to actually arrive. Here, we have hard requirements for those events to arrive. So we actually have things like watchdogs, and if you drill into this, watchdogs which are waiting for events to arrive. If they don't come, they will raise events internally, which other things, monitoring things react to. But it's a reliable delivery eventing system that we require here. For inside the fulfillment service, we have, yes?
You see that little number in the bottom corner of the screen?
Oh, yes, I do. Actually, it's
but we have 3 slides to do as summary.
Okay, so queuing system in the middle, and then we have a request response thing up there. So let's go back to the slides then. So when to use workflow, when rules, when code, you will know. If you feel comfortable in the situation and you want to use code, use code. If you can solve your thing using workflow, you will know. Just study the workflow systems. If you can solve something with rules, you will know. You just need to take workflow and rules as a natural set in your tool set. If you accept them as being on equal footing with C# code or VB code, it will come naturally. You will intuitively know whenever you feel is appropriate. We work hard to make you feel less that code is always appropriate and feel more than rules and workflow and the other abstractions are more appropriate. Do you want to speak to the takeaways, Steve?
No, Clemens, I want you to, because you're going to be the one who's late, not me.
So Steve says, distributed systems architecture is all about smart composition of a set of simple patterns, and I have not been able to disprove him with that large diagram. And it was not crafted, this is not crafted to underline Steve's story, but it's just, that's the way how we build a thing. Abstraction and moving logic into configurable metadata will greatly enhance the flexibility of your applications. And WCF and WF and BizTalk Server are actually creating a bunch of those abstractions for you already in code, already in configurability islands, already in an infrastructure that you can leverage by just creating applications, creating more application pieces in a declarative way, and that's the way forward. We're certainly not going to not out to steal away VB and C# from you, but we're certainly thinking that a higher level of abstraction, thinking about systems in a greater way, thinking about systems not only on a service level or contract level, but really spanning the whole architecture, finding ways how to actually describe those things in tooling. That's the way forward, and we're working hard to get that done.
We got to tell them about the Iron Architecture.
Yes.
Where there's an event that I learned called the Architectural Broad Jump. From a standing start, how far the architect can go from reality with one jump.
Yes.
If they fill out their forms, they may win a pony. And we're going to be down in the lab whenever we can. We were already down in the Ask the Experts for a couple hours. And people can only take photographs of you and not me because I break cameras.
Yeah, so
thank you very much.
Thank you very much.
Thank you.